At its very simplest, Tomcat is a web server. To expand on that a little bit, there are a series of Java specifications that define a way that web applications can be written, and Tomcat implements those specifications, and it's one of a number of servers that do. So a web application developer can write their web application using these standard APIs, and then it can run on Tomcat, it can run on Jetty, it can run on WebSphere, it can run on WebLogic, and because it's the same interface, the same standard everywhere, you can move your application from one to the other and it will just work. But at its simplest, Tomcat is a way of running websites. It is completely separate from the Apache web server. However, if you wish, you can get the two to sort of work in cooperation. So one of the things that Tomcat doesn't do within itself is the idea of load balancing. So if you've got more load than one physical server can handle and you need to spread it between multiple ones, you need something to spread that load. What we often see people doing is putting Apache web server in front of it because it can do the load balancing, and then it sits in front of Tomcat and it spreads the load between the different Tomcat instances and then brings the responses back together and sends them off to the users. And we have quite close cooperation between bits of the Tomcat project and bits of the Apache web server project, because we have effectively our own protocol that we use to do some of that communication. So we work together on new features, developing that integration of that.
I am focused on the Apache Camel project, so I am currently a committer, a PMC member, and a member of the Apache Software Foundation. I have been that for a long time. I've been a committer for the Camel project for, as I said, about 12 years. My current role is as a professional open source developer. I'm employed by Red Hat, and Red Hat uses Camel in the middleware products. So I am currently heavily involved with Apache Camel there. Camel is basically used for integration. It's the Swiss Army knife for integration. IT organizations today have so many different IT systems, and they need to be integrated, connected. Data needs to be transferred from different systems, many of them. So there are so many different protocols, languages, and IT systems, and operating systems, and whatnot, and data formats. And Camel is sort of like the glue that sits between, and you can more easily integrate them.
I started with more system integration, so more project related to application runtimes. So running some stuff, an application easily for you and providing a lot of features you can leverage. So I started with this kind of project at Apache. Now I'm still working on this project, still very happy and yeah, it's still my project that I like a lot. I'm also working on big data related projects. So big data like Apache Carbon Data, for instance, is a database designed for big data. I'm really happy about this project because it's one of the first projects that I did with Chinese guys, and it was really great. Around big data, I'm also working on Apache Beam, which is a very key project, providing an API, so a language that allows you to design some big data pipelines, so distributed processing of data. So this the project historically on which I'm working on. There are another project which is named Apache Unomi, is more about user profiling and GDPR and stuff like that. And the thing that I really like is there are some connection between all these projects. The connection is between some projects use others. For example, Unomi is based on Apache Karaf, which is one of the projects I'm working on for a long time. Beam are using Flink and Spark, so there are a lot of connection between the projects. It's what I like, yeah.
I've been involved with a few projects, but I think the ones I've been involved most were Jackrabbit, Apache Jackrabbit, and Apache Unomi. So Jackrabbit, I know, is foundation of a lot of different let's say content management systems. So you have companies like my own Jaya, Adobe, Magnolia, that are all using this as the infrastructure for building content management systems. For Apache Unomi, we started this really as a project for our own needs. So our needs were simple at first. It was just to be able to collect in real time the behavior of people using our CMS. And so that was sort of the initial use case. What was really fascinating was to see that once this project was inside the Apache Foundation, people found new usage for it. And one of the most surprising one was a project we just learned about a few months ago. And it's somebody that built an integration with Slack and SMS systems. And they would use Apache Unomi as sort of the orchestrating system between those two external systems. And this was all done to manage healthcare, basically trying to follow people that are suffering from addictions, and just to make sure that you're actually using the system to make sure that they don't get lost. I mean, they'll get forgotten in a way. And so that's really something quite incredible, because you design a system for a specific use case, and then suddenly somebody surprises you with a completely different one, and that's what I love about Apache Project.
OFBiz is essentially this open source ERP application development framework, and it can be a little bit intimidating. It has a broad scope of functionality, and it's one of those cases where if you're not careful, people ask you, what does OFBiz do? And you say, oh, it does everything. But that's not the best answer, surprisingly. What we do is take OFBiz and then we shape it and form it to meet the specific needs of our clients. So ultimately, we are in the business of executing strategies, right? We like the business person to be able to set the strategy, and then we have a technology strategy support. So we want to understand that business strategy really well. We want to believe in it. If we're going to commit to the project, we want you to be successful. And then we'll take OFBiz and we'll shape it and customize it and extend it and configure it and adjust it to make this bespoke solution for our client that does exactly what the business strategy dictates.
I think one of the great things about RDF, and even I did not realize before getting too much into this, is that you can express anything in this format. So I think that really leads to a lot of applications or possible applications for this data. So you can say the sky is blue, or you can say Adina is an associate professor. But you can also say store data that is financial data or just documents, and say this document was modified at a particular date, and you can build on top of these applications, for example, that keep track of data provenance. One of the applications of RIA in the Navy is drones with intelligence, artificial intelligence, and image recognition. So you can have these drones that fly around, and they can try to do image recognition. For example, this was a reconnaissance and target acquirement. So they try to recognize people in this case. Of course, they run image recognition algorithms, and they try to find a particular person or a particular target building or whatever the target is. And then you can communicate with the drones, actually, can communicate with other computers which are on ships or they are on the ground, and they can coordinate an entire action. And somewhere below all the artificial intelligence and all the communication, a lot of data was actually stored in RIA. So because of this flexibility of the data format, you really can store a lot of data, a lot of different types of data in RIA. And what we're trying, RIA is very scalable, so you can store billions of triples, and you can ask queries in seconds, milliseconds, and that really helps in some of these applications.
CloudStack is an infrastructure as a service platform, and what that really means is that it abstracts away all of the complexities of offering a infrastructure platform, and essentially it does that by providing an API and a user interface for a number of very complex actions, and makes that very simple to use and consume. CloudStack is essentially software that allows you to have individuals in your organization provision resources according to a set of rules, and those could be business rules or technical rules, and allow them to get things done in a fast manner, because they've essentially been delegated some technical and organizational authority to get things done. And this provides essentially a technical layer that allows people to action things. So you could have an individual developer who needs a test environment for testing software, and rather than asking people to stand up a test environment for him, he would make an API call, or he would log into a user interface and stand up that test environment himself. So CloudStack's really about providing access to a set of organizational resources and letting you actually get work accomplished, but without forcing all of the complexity of having to know about how to provision. So it removes some of that complexity and allows you to focus on getting the underlying work accomplished that you need to do.
I got involved with Tomcat about 15 years ago. I was working as an IT consultant, and we were doing some work with SSL authentication, and the product we were using wasn't working properly, so we switched to JBoss, which at that time had Tomcat embedded in it. And we got a lot further with it. There's one little thing it didn't do. So because it was open source, I was able to look at the source code, find the comment that said, "To do, must make this configurable." I thought, brilliant, I can do that. Submitted a patch, had that patch pretty much torn apart, very nicely, but it was torn apart, showed me all the ways I should have done it better. So I took that advice, improved the patch, submitted it again, and it became part of Tomcat. And I found it was something I really enjoyed. And as part of researching that, I'd realised that, there's all these other hundreds of bugs that need fixing as well. Perhaps I'll do some of those. So I got involved that way, started fixing bugs, and have essentially been doing that ever since. I think that the thing that I get most satisfaction from is when I started my involvement in the Tomcat project, we had something like 600 plus open bugs. These days, when we do a release, we have 0, essentially. We've got a few open enhancement requests, but the actual bugs, they're fixed. So actually working through that list of open bugs and reviewing them and closing them properly, not sort of it's been open for a year, so we'll just close it because nobody's looking at it anymore. Actually reviewing it, examining it, working out whether it's really a bug, if it is, fixing it, if it's not, explaining why, and closing it legitimately. I think getting the bug list down to 0 for Tomcat is something that I'm particularly pleased that I've had a big part in. What often surprises me is all the places that Tomcat's used that I never knew about. I was at a conference and somebody was giving a talk about web application performance and tuning. I thought, that could be quite interesting. It's an area that technically I like to hear about. And so I went along to the presentation and discovered that the NFL in the US, all their websites were based on Tomcat. Whether that's still the case, I don't know, but back then it was. eBay uses a lot of Tomcat, and I didn't know that until eBay turned up and said, but yeah, we're using a lot of Tomcat, and we get quite a few page views. You might have heard of us. And there are these few places where it's not quite as quick as it could be. Here are some changes we've made. Could you help us put them into the code? We said, yeah, absolutely. And we worked with them to incorporate their patches. So what I find is that lots and lots of companies are using Tomcat, taking advantage of it and doing all sorts of things, whether they be commercial entities whether they be educational institutes. The fact that it's there, it's available, and people can make use of it, I think is great.
I sort of was very happy to see sort of the public interest with all this Industry 4.0 digitization and production industry sort of coming up, because it was all about software Apache, for example, had to offer. It was sort of like big data, machine learning, cloud technology, and all the stuff we have. So I was really looking forward to doing industrial IoT projects, because I have to admit, I'm not that sort of cloud guy. I really like physical things. So for me, it's more fun to sort of control some huge engines and robots. So I was really looking forward to that, but it wasn't happening because I did a little research why that was the case. And I finally found out the main problem was that we weren't able to talk to the industrial hardware because they were using completely different technologies, completely different protocols. So my current main focus is a project I was happy to initiate. It's called Apache PLC4X. So this is our little mascot. And what we're trying to do is we're trying to build sort of a universal library for communicating with industrial hardware. They sort of use protocols to exchange information. And these protocols are usually very highly proprietary. And so a device from manufacturer A can usually just talk to the devices of manufacturer A, sort of resulting in sort of a vendor lock-in. And what we're doing is we're sometimes implementing those protocols by reading the spec or by implementing the spec, sometimes by reverse engineering the protocols. And hereby we're making it possible to communicate the same way with any industrial hardware.
We usually use the term industrial IoT or IIoT, as we do not work with like small gadgets or smart watches or mobile phones or whatever, but we usually work with machines, big machines. I personally come from the south of Germany, we have a lot of machine manufacturers there, and all of those machines have controllers. Some of those controllers are 20 or 30 years old because they're meant to be robust and work. And they are rather complex pieces of hardware, but not optimized for interoperability, but rather to be robust and provide real-time capabilities, safety functions to control those big machines. And those machines can really weigh 50 tons or even more and be several meters long and high. Basically, forever there has been the gap between the machine infrastructure or the network where the machines communicate with each other and the IT landscape. So usually we have different networks in those factories. Now with all the capabilities we have to store data, to analyze data, to extract information, people want to use the tools we know from the big data area, from the AI research, from the regular application development, and want to apply those techniques to the machines or to data gathered from those machines. Many of those protocols you can use to speak to the machines are proprietary, old-fashioned, and what we try to do with the PLC4X project is basically bridge this language barrier. So we want to provide drivers, possibilities for everybody in IT to speak to those machines and those controllers. So that we basically open up the door to use the regular IT landscape to work together with machines and production sites. For example, we have customers in the foundry area where they have big machines that produce sand cores. So basically sand is compressed to build a core, which is then used to create a hole in a casting. And the process is quite complex. There are chemical processes involved and physical processes involved. And up till now, it's some kind of modern alchemy, because nobody knows exactly how everything works together, which parameter to adjust when. And by using PLC4X, we're able to extract all those parameters, relate them to the quality of the end product, and really close the feedback loop to get a better understanding of which processes influence the product.
one thing I noticed was that a lot of people have been building database management systems, and I use the analogy, it's kind of like climbing a mountain, that if you're a mountaineer, the first part of the journey is always the same, and it's pretty boring because you're just walking up through trees and so forth, and you have to get to 10,000 feet before the snow starts. And so building database management systems is kind of like that. You have to do a lot of basic stuff every time you build one. And there's a lot of people in Silicon Valley and around the world building database management systems and all doing the same stuff. So the project that I'm working on, Apache Calcite, is an attempt to kind of skip over the boring bits of the mountain and get into the interesting area. I noticed that when people build a database, they do a lot of the same stuff. And what I wanted to do is eliminate some of that common drudgery by building a toolkit, a framework for building a database management system. And so Apache Calcite is that. We took the core parts of a relational database, such as the parser and the query optimizer, and repackaged it in a way that people could use it as a toolkit to build their own database. And the result of that has been that it's been a collaboration across many companies and many individuals, each of whom is trying to build a data management system or a database management system. So we have a lot of collaborators from different companies, each of whom have similar requirements, but not exactly the same. And so when I'm working on Apache Calcite, I'm working with peers who have the same goals as I do. They might be in companies that are competing with my company, but it's a place that we can share work, and we can talk directly to each other rather than having to go via, companies, go via managers or via companies' legal departments. It's a direct communication with my peers, and I find that very exhilarating and very productive. Calcite has snowballed, as it has become more stable and more fully featured, and its reputation has grown. We find more and more companies and projects just using it almost like the default option. If you're going to build a database, start off with Apache Calcite. You're crazy to build a SQL parser, why don't you use Calcite's parser? That kind of stuff. And we hear that more and more. It's taken a long time to become an overnight success. I mean, it's taken 7 years, but we just hear, it's actually really nice to hear of a database hitting the market and then finding out that it has Calcite inside, and we're not even aware of it. That's one of the wonderful things and frustrating things about open source, is that people might be using your software and you don't even know about it until they hit a bug. And then they have an incentive to get involved in the community and try and figure out how to solve that bug.
So we have two major projects in Apache Foundation right now. Both are top-tier projects. One is called Double, which is an RPC framework, and the other one is called RocketMQ. It's a enterprise level or enterprise grade message queue. Both are very successful in China before we donated them to Apache Foundation. But the good thing about putting them under Apache Foundation is now we have collaboration from the community. So now they both have become not only de facto when people are looking for RPC frameworks or message queues, but also they are actually becoming the projects from the community. For example, RocketMQ, we have PMC members from 5 different companies and 12 of them. So Alibaba is no longer in control of that project anymore, but we love to see it. We see new features we never thought of inside of Alibaba that's being developed, being proposed, being developed in the community. For example, we were a heavy-duty Java shop. We never wanted any SDKs in other languages. But since we donated this project and graduated from Apache Incubation, now we have SDKs in C++, in Golang, in .NET, in other languages as well. So it has absolutely being active because the community has driven that way. And the same thing with Double. So there are so many forks before that people were using it, taking in depth of how they would adapt or use Double inside of their own companies. But now we've, under a nice umbrella, people actually come and bring their ideas to the community and making Double more modern or cloud native in this world. So that's the value that Apache Foundation has added to us for Alibaba and for the community as well overall in China.
So the community really flourished within OpenOffice, and it was a global kind of distributed community that we built over time for an office productivity suite that was pretty popular in its time, available on multiple platforms. Of course, now we have Apache OpenOffice, so that was some of the history of Apache OpenOffice is very steeped in the Apache Way because of the mentorship that we had from Apache founders and the Apache community. The next project that I was involved in was Netbeans the Java Ide, and I got involved in building a governance model that really included the community as well. Netbeans had been acquired by Sun at that time, and there was some tensions in terms of how the company control versus the community's original way of working. So we found a model that worked for the community and for Sun as well. And it's really great to see that Netbeans is also an Apache project. So we can see that my kind of early days of open source were very connected to Apache and not just the community, but also it's great to see those projects now living on in Apache.
The first patch that I submitted was early 2003, and that was to the Apache Ant project. We had written some testing tools using building on top of the Ant framework, and we needed some enhancements to actually make Ant be able to read databases better. So that's how I got involved, submitted some patches, got some feedback. Even though we were using Ant, which had an XML flavored syntax to it, for our testing purposes, we needed a little bit more scripting capability. And so I actually started using the Groovy language to script the Ant steps that we were using for our testing. And many years later, it came full circle when we moved Apache Groovy into Apache when we were previously hosted at Codehouse, and that was shutting down, and we moved the Groovy project to Apache.
I've worked for a bunch of companies, and lately I've worked at Google for 5 years, and I've worked on Google Cloud Dataflow. It's a big data processing system, and the client for it was always an open source SDK, and some other people picked it up and made translators for Apache Flink and Apache Spark. And at that point, Google decided to collaborate with them and try to begin Apache Beam, which would be this sort of portability layer, so you could author your big data processing and you could run it on Apache Spark or Apache Flink or on Google Cloud Dataflow. So that's how I came to Apache really through this really sort of top-down initiative to donate the code to Apache and start incubating.
So at Jewelry Television, so humorously enough, these types of, analysis platforms or, tool sets, they're almost unheard of in the physics community. So once I moved to JTV, we started working on our big data platform and big data stacks. And, then I've really started to learn more about, a lot of these types of tools, specifically Spark and Kafka and things like that. And I was like, oh man, I really want to learn more about these because, these are tools that can solve a lot of problems. And I heard, it's like, oh yeah, Uber's using, Spark and, LinkedIn is using Kafka for a lot of their messaging, and then I guess Rocket MQ and all that kind of stuff, and I was like, oh, this sounds like a lot of tools, it's like my data, for a lot of what we're doing, it's like, wow, we'll never approach those kind of those kind of sizes. It's like, yeah, you're trying to manage all of Twitter's, tweets or messages in LinkedIn. It's like, oh yeah, we use Kafka to do some of that. I'm like, okay, Cool. Then we can certainly handle our data rates. So, being able to, kind of come to the community and learn from it and talk to people and, kind of hear what other people are doing.
Hadoop is a program that lets you run your program on a lot of different machines at once. And part of having to run on lots of machines at once is, in fact, dealing with failures. Because if your machine at home breaks every 3 years, that means if you have 1,000 machines running, there's going to be 3 machines breaking each day. And we, in practice, run on clusters of 5,000 machines. And so you'd have lots of machines breaking every day. So you can't have the humans need to do anything. Everything has to be automatic. One of my friends at LinkedIn was running the clusters there, and he was trying to convince his bosses that they didn't need to keep buying expensive hardware. And so he pulled up the list of machines in the meeting and said, please pick one. And they did. He shut it down immediately with just a halt. No warning, no graceful shutdown, just a halt. And that halt didn't cause any pagers to go off. Nothing had to be done. All the data that was there was immediately just put onto other machines. From the machines that were still up, the workload had already run onto other machines. And so that was automatically handled. The failure was handled completely automatically, and nothing had to be done manually to keep it going. So an example of that kind of program, well, the first example of that kind of program was building an index of the web. So in order to do a search engine, you really need to have a complete understanding of not only all the pages on the web, the text they contain, but how they all link together. Because the pages that are linked by more pages at various sites are a better page, and the text that they're linked with actually is a better description of what's on the page than the text on the page itself. So you actually need to analyze the whole web, build this map of all the different links. And so when we were at Yahoo, we had 1 trillion pages and 10 trillion links, and we'd build a map of that entire graph, run algorithms over it to figure out which are the best pages, what search terms should be on each page. And that was all done with Hadoop by the time we were done. And we could run the process on Hadoop much more quickly than we could do it on the previous system. The previous system had taken a month to run. With Hadoop, we got it down to less than a week.
Yes, the idea of Calcite did happen outside of the ASF. It was originally a project called Optique. I had the idea, and actually I created the project by actually cutting down a previous open source project I had. And around 2012, this was the peak of the big data movement. Apache Hadoop was very successful, and there was a lot of activity in creating big data technology. Notably, a lot of this was doing similar work to databases, but the people building it were at pains to say, this isn't a database. This stuff is so different, we don't need SQL. And I kind of disagreed with that. I could see that, big data and Hadoop, it was data management and people were going to need SQL eventually. So it made sense to take this project that I'd been working on as an individual in GitHub. It made sense to bring it into the Apache Software Foundation so that it could start to grow a community and start to grow adoption within the other projects and by the other companies that were pushing the big data movement. So I actually joined Hortonworks, which was one of the main companies that was backing Hadoop. And they asked me to carry on working on Calcite, but also help Hive put a query optimizer into Hive using Calcite. And at the same time as that, I was working with the Apache Drill project, which was written by MapR, a major competitor to Hortonworks. So virtually from day one, I was paid by one company to work on technology which was being used by that company's arch competitor. And everyone was fine with that because that's how it works. Basically, we were all creating value. We were making I won't say we were making the world a better place, but we were building a very interesting, powerful technology stack that made it possible for both of our companies to release really good products for our customers. It's not a zero-sum game. That's the kind of the message of open source. If I do something that makes my product better, and I happen to make your product better, that's great.
Community was always a really important thing for us, and when Codehouse was shutting down, we were looking for a new home for Groovy. There was lots of people who've invested in the Groovy technology by building frameworks and libraries on top of it. And what we really wanted was a place where all of those people could safely park Groovy and all be contributing, and a community could thrive, and no single vendor could come in and take over the language and direct it in a direction that might impact all of the other players in the Groovy ecosystem. So the ASF was a great place to bring Groovy, and it's the community ethos that was in Apache mirrored very much the kind of community that Groovy had been fostering outside ASF, and that was the big attraction for us, and what we found was a really important part for the ASF.
So we produce tons of data basically by extracting all those parameters from the machines. And this is exactly the problem IoTDB solves. So this is one project we use to store those data for later analysis, to have it long-term available. If one sees that there's a problem, several months later, you can always go back and look at the data, and they are easily accessible, but at the same time do not consume much memory. So this is one puzzle piece basically into the whole picture. And another one is data analysis, where we have several projects in the ASF. One is Ant, which is a framework to build exactly this kind of analytic applications running at the edge. But we also use other projects like Apache Flink, which is very well known as a streaming framework, or Apache NiFi or MiniFi, which also is a nice way to analyze data. What we do then in detail is rather specific to the use cases that may be very simple questions like how long did the machine operate in a specific time range, but can be more and more complex, like recognizing specific shapes to see, for example, that the energy consumption is abnormal, which could be related to some kind of failure or aging process. So there's a wide range of application-specific things. And what we are trying to do is to help to populate the ecosystem in the Apache Foundation to make it easy to build together this kind of application from several building blocks.
I'm the Vice President of Apache Labs, which is an internal innovation area where people can, existing members and committers can create their own projects with very low overhead. And I was on the James project for many years, and I was Project Management Committee Chair of James for a number of years. Labs is available to any committer. They can subscribe to the Labs mailing list, and they can tell us what their idea is, and we'll spin up a mini project for them that has all of the infrastructure of Apache behind it. And then they can experiment in there and attempt to get other people interested in their idea. It could be an experiment that is time-boxed, or that they achieve a particular goal and then it's over with, or it can be something where they want to collaborate and try things out and see if there's a critical mass behind it, and then they can attempt to become an Apache project with it. It was created at a time before GitHub was a thing. And I think most of that activity is now supported on GitHub, so we're seeing less interest in labs. But times change, and the trend is maybe the trend will swing back the other way. And perhaps if people are watching this video and they think it's a good idea, they can subscribe to the labs list and come and create a lab.